Bismillahirrahmanirrahim. This is part B of lecture 4 on Descriptive Statistics and Islamic Approach. We will talk about how we can reduce a large amount of data to one number. In a traditional course, this would be called measures of central tendency, because the idea is to pick a central number which represents the whole data set. But we will treat the topic very differently, and we will illustrate this concept by discussing inflation. A large number of price changes occur in the economy, but we use only one number, the inflation rate, to describe all of these changes. So many numbers, many different price changes are encapsulated into one number which represents all of the price changes. How this can be done, what it means, this is the topic of this lecture. The traditional approach to this problem is due to Sir Ronald Fisher, the father of modern statistics. He makes the assumption that the data comes from a nice theoretical density. If you make this assumption, then basically the data describes the density, and you can think of the data as being a theoretical density plus some random errors. So now the goal is to look at the data and to find the theoretical density which generated the data. And a lot of the data is just noise, and so basically we can get rid of this noise, these random errors, and find the density. So there are some very elegant assumptions about the underlying density. Normal density is the most important one, but there are others also, under which you can find what are called sufficient statistics. That is, you can reduce the data to one or two or a few numbers, and in these numbers is contained all the information that the data can provide about the underlying theoretical density. So these are conditions, these are theoretical assumptions under which you can reduce the data to just a few numbers without actually losing any significant information. But what if the data is not generated by any underlying density? Then simply it cannot be reduced. So what is the justification for assuming that there is a theoretical density? The only justification is that it allows us to reduce the data. It doesn't. There is no way for us to verify that the data is actually generated by some nice theoretical density. So this assumption has been so deeply embedded that basically modern statistics starts by assuming that data set is generated by some density, and the idea that the data set may not be generated by a density doesn't even exist in the standard approach. So it is time to move beyond this fairy tale assumptions which allow us to reduce the data and think about what we do when convenient assumptions are not available. So there is an alternative which is now emerging, and this alternative is based on narratives, based on qualitative analysis. What are the stories that we can tell by using this data? And basically the story has to be coherent, it has to explain what we are seeing, it has to have causal structures. So this is what we will try to illustrate. The essence of an Islamic approach is to use the appearances to look through these appearances to the underlying reality, to look at the miracles that we see in the real world and deduce the existence of God. So now the question that we want to ask about this process of data reduction are, why do we want to use one number to represent the whole data set? And if we want to do this, how we can compute this number, and what does this single number mean? What is the relation between this number and the data? And also, what's the relationship between this number and the real world? Basically, the picture is that the real world generates the data, and then we calculate one number from this data. So what is the relationship between this number and the real world? And we want to ask, what is the effect of this data reduction? What happens in practice in terms of policy when we replace the whole data set with one number? Now, this question cannot be answered in the abstract. We have to think about it in concrete, particular, special examples. There is an important pedagogical principle involved here. Whenever you have some abstract theorem, some principle, some philosophy, then to understand it, you have to reduce it to a special case where you can exactly see how it works in a real life concrete case. So you understand the abstract by reducing it to the special case. So we're talking about this abstract idea of reducing a lot of data to one number. Now you can't really understand this in the abstract. You have to see how this thing works in a real example. And that's what we are going to do when we look at inflation. Basically, inflation is the amount of increase of price, but there's no one price. There's lots of commodities with different prices, and each of them increases in a different amount. So when we want to take all of these prices increases and summarize it by one number, then we are doing a data reduction. And now what we will look at is how this thing works in this particular case. We look at the actual data in Pakistan from May 2019 to May 2020. So in May 2019, the food and non-alcoholic beverage group, this is a group of commodities, it has a price index of 118.58. What this means is that if we take a collection of food and these beverages, and then you buy them in the market, you will have to pay 118 rupees for this. Similarly, the second grouping is alcoholic beverages and tobacco, and the price of this is 121. And similarly, clothing and footwear, a particular category of goods, and we will see this in more detail, costs 120 rupees. And so basically you take a basket of these goods, housing has 122 and so on. So we have all of these categories of goods, and all of these have certain price indices, and these are in May 19. And if you look at the same category, the same group, so the same collection of goods, and you try to buy them in May 20, then for the food which you had to pay 118, you will have to pay 131, which is a 10.9% increase in prices in the food group. In the alcoholic beverage group, you have a 19% increase. In clothing, you have a 9.5% increase. In housing, water, electricity, and gas, you have a 6.5% increase. And similarly, for other categories of goods, you have different amounts of increase. Now, the rate of inflation is calculated to be 7.3%. So what does this 7.3% and how does this come from, the numbers? Actually, if you calculate the average of all of these prices, you will get 6.9%, not 7.3%. Why? Because the average just adds them all up, but the rate of inflation doesn't average them with equal weights. It actually gives more weight to those commodities which are purchased more heavily, and gives less weight to those things which are less important in consumption. So the point that I'm trying to make here is that we have a collection of about 12 or 13 categories, and each of these categories has a different rate of inflation. So what does this number 7.3% mean? It is not even the simple average. The simple average is 6.9%. And also the issue is how it is computed. And is it something that we should be doing, even that taking all of these different kinds of prices and trying to find one number to represent them all? And if we do it, then what is the effect of this? In fact, this number 7.3% is the so-called headline inflation. This is the number which is written in the newspapers and which the public worries about. So this has significance, But what exactly is this significance? That's what we'd like to. So before we start making calculations, we need to know why we are making these calculations. This part, conventional statistics does not tell you. It just says, take the numbers and calculate the mean, calculate the median, calculate this, that, and the other, without really concerning ourselves with why we are making these calculations. And now, when we ask the question of why, we need to go beyond the numbers to the theory which generates the numbers. So in economics, there is something which is called the quantity theory of money. Suppose we take all the currency, all of the money, and just add a zero at the end. So 100 rupee is now 1,000 rupees. And we also add a zero at the end of all the prices. So something that cost 10 rupees will now cost 100 rupees. So obviously there is no change that will occur. It's just a renaming of the money and the prices, and there will be no real change. So this is basically the idea of the quantity theory of money, that if we increase the amount of money, let's say we double all of the money, then we will just double all the prices and nothing else will happen. So if this is so, then basically all of the prices will double. So all of the prices will increase in the same proportion. And if this is so, then there is no harm in talking about inflation. In that sense, the rate of inflation will be the same in all commodities. And that's where the idea of the level of inflation comes from. So this is the one case in which inflation makes sense. But what happens if all the prices are different? All of the price increases are different. Then there is an issue of, can we use one number to represent all of these changes? Well, this depends on why we are doing this. What is the purpose of doing this? So one of the purposes is to evaluate how the government has been performing. So if the government succeeds in keeping inflation rates low, that means that the government performance is good. Another purpose for looking at the inflation rate is to decide on monetary policy. If the goal of monetary policy is to keep inflation low, and so if the inflation rates are good, that means that the monetary policy has been successful. There is another issue which has to do with public perception. How are prices behaving? The public's income and wages demands depend on what they think the inflation is. They would like to have more wages if they think the inflation has gone up. So the effect of this inflation is different for consumers. It's different for businesses who have to think about their labor costs and how to price their goods. And it's different for the financial sector because they have to set interest rates on their loans depending on the inflation. So this inflation number has very different implications for different sectors of society. As we will see in general, for different purposes, different numbers will be required. So one of these purposes is the sensitive price index. This is used to judge the impact of inflation on the general public. The masses in Pakistan are very poor, and so they're not concerned about the prices of cars and houses, but they are concerned about the price of food. This price, the sensitive price index, will tell us whether there will be political unrest, whether the party in power will have widespread political support, if they have managed to contain inflation in the areas which matters to the general public. This will have an impact on inflations. This will impact on whether salaries should be adjusted and how much for inflation. Also, it will have impact on social protection programs. How much money should we be giving to people to enable them to buy food? It matters for where to draw the poverty line, to count the people who have less than enough income for their needs, and to count the people who have more than enough. The poverty line also depends on political issues, which we cannot discuss here. So all of these questions are addressed by the sensitive price index, and actually we will see that different types of indexes would be useful for different purposes. So how can we change the index according to the purpose? Well, there are two main factors that one can use. One is the choice of goods, which are the things that we are calculating for our sensitive price, and the other is the choice of weights. How much weight should be given to which commodity according to determine the sensitive prices. This data set shows the actual data for the sensitive price index. It lists all of the commodities that are used. You see, you have wheat flour, basmati rice, mutton, chicken, milk, uh, powdered milk, eggs, cooking oil, pulse, dal, potatoes, onions, tomatoes, sugar, tea, oil, electricity, so on. So these are the things which matter to the general public. And what we do is we decide on a unit. So for example, here wheat flour is, the unit is 10 kg. And so how is this unit? It turns out it doesn't matter what unit we choose. We will choose a unit which just is easy to price in the market. So we look at a 10 kg bag of flour and we find that the price is 182 rupees. We look at 1 kilogram of broken basmati rice and we find that the price is 37 rupees, and so on. So as we will see, so all of these prices, they are used as data to calculate the sensitive price. Now we will see exactly how this is done in the next slide. So I'm going to show how to calculate the sensitive price index on an illustrative data set, not actual, just to show how it is done. So we take a subset, a small set of articles from the previous list of 53 items. And so we have wheat flour, and its price on 25th October 2018 is 182. Then we price the same 10 kgs on 25th October in 2019, and this price is 198.9, which is an 8.8% increase. Similarly, we go through the entire list. So we find that milk fresh 1 liter cost 30.5 in 25th October 2018, and the same 1 liter cost 35.4 in October 2019. So there was a 16.26% increase in prices of milk. And similarly for cooking oil, potatoes, tea, petrol, we have different amounts, with some categories actually being negative. This was an unusual year in that the price of oil went down, and that resulted in a negative increase in negative inflation in that category. So we have different kinds of inflation in different categories. Now the question is how to come up with one number. As I've said, a simple average is not correct because it doesn't correspond to the relative importance of these. So we look at the sales and we use that as the weightage. So for example, wheat flour, the sales were 10.9 million out of the total budget of 57. So this is an amount of 18.9%, and that leads to, this is the weight we attach to the inflation rate in wheat. So similarly for rice, the inflation rate is 18%, but the weight is only 3.3% because rice basmati only has 1.9 million rupees. So it's only a tenth as important, 1.9 compared to 10.9. Compared to wheat, rice is much smaller part of the budget. On the other hand, milk is a larger portion of the budget. It takes 16.8 million. So the proportion, this comes out to about 29.3%. So that's about almost 30% of the weight goes on milk. And so this 16% inflation in milk prices will be weighted by about 30%. So similarly, when we add up all of these weights and then we take multiply by the rate of inflation, we get 11.99%, and so that's the rate of inflation of the sensitive price index, not the overall consumer price index, which would include a lot more and different commodities. So this is just one of the inflations. There are many kinds of inflation figures that we could come up with. There's a consumer price index, there's a wholesale price index, and there are actually many different types of inflation numbers which are relevant for businesses, for consumers, for the financiers, for real estate. All of these have different inflations that matter for their decision making. So there's no one inflation number, and there are many different ones, and unfortunately there is no clear understanding of how much subjective and arbitrary decisions go into calculating these numbers.